record. Okay, so I'm going to present the Dpf Avionics presentation that I have never actually looked through, but I'm sure there's going to be some useful information in here. So DPF, so that's dollar per foot. We don't have to go through that. We can, if you have questions, you can always ask about that. But it's a competition that they're doing to make money by launching a rocket. So these were the 3 projects that existed last year. So I was the project lead for Comp Rocketry, and then Carmen was trying to go to space, and Ellery was trying to build a rocket engine. We've all decided that those 3 things, we didn't really have the resources to put all we wanted into all 3 of them. And I'm sure that COVID made the decision easier too. But that kind of shows what we used to do, a lot more split up. Now DPF has kind of consolidated all of those resources, which is why. So like each of these had an avionics team before, and now they're kind of all working together. Some other fun stuff. Avionics Overview. So there's kind of a bunch of different systems. So a lot of the stuff we've been working on so far here has been like Arduinos and soldering Arduinos and like building boards. So that really works a lot into the kind of like control deployment event system. That's more of like, we've been talking about how you actually do that. But that's kind of the thing we need to do. So we need to, as this rocket goes up, we need to make sure it comes down safely. So we have parachutes that come out, and those are controlled by computers. So essentially, the computers we make are pretty much to, one, telemetry, so measure how the flight went. So that's like accelerometer. So the sensors I was talking about last week and that we're going to work on next week, actually using them, that is what telemetry is. It's measuring like how fast the rocket's going, how high it went, all that fun stuff. Oh, we got someone new. More. What was I looking for? This got me all out of whack. Cool. Sorry. Okay, so also there's stuff about radio. Ben may or may not talk about radio at some point. I think we've decided that that was going to be too confusing because radio is a very confusing topic. So electrical systems, essentially, this goes over what DPF is doing for the electrical systems. So there's a processor called an STM32. So that's what they use as kind of the brain of the control boards for the rocket. So we're also looking at stuff like deploying parachutes, and then also talking to the liquid rocket engine, which has a bunch of sensors on it to make sure it's not going to explode. So a whole bunch of software systems. This is not the best presentation way to show it, but essentially talking about how the software works down on this board, how we're actually doing things like reading data and processing that and making decisions based on the data that is collected there. Electrical, so this is the actual like PCB design, so the stuff that we covered in that lesson where Ben went through and showed us how to use Eagle. The same kind of thing. Ben designed a whole bunch of boards here, and John has also worked on them at some point. So for example, there's the dual deploy boards, which I think is the closest to what we've worked on so far. It's essentially a little board. I'll try to find a picture of this after, but it runs Arduino, so it's the same.
I have a picture.
Oh, is Matt just gonna hold up a board?
No,
Yeah.
Actually, I handed mine off tonight.
Okay.
I'll put a link in the chat.
Because I know Matt was working on that this week, I heard. So yeah, that's the dual deploy board. It's Arduino. It's a good baseline for kind of more of the stuff that we'll be working on in the spring. A whole bunch of stuff talking about fancy words that you'll learn at some point. Yes, I get pings when the chat is sent a message.
A very long URL with a picture of a dual deploy board.
think I pulled that. Yeah, there you go. You should be able to see that on here now. So this is a little computer called an Easy Mini. If you see where my mouse is circling right now, so that has a little altimeter on it, like the sensors we looked at last week. And as you go higher up, the pressure goes down. It tells how high you are, and then it fires signals down these wires to control this other board that we built to release parachutes. And now I am confused here. Milestone, this doesn't matter. This doesn't, no, this matters. Okay. That was very high level. Close, there we go. Okay. So I'm trying to find. Let's see if this is in here. This is. So this is the, let's show the board. So this is the full flight control board for the Redshift project. So Ben made it. Actually, not that long ago. Apparently, this one was from September. But this is essentially what my plan is for the spring, is for us to build a smaller, simpler version of this board. So that would involve writing code to run on it, designing the PCB itself, and then also before that talking about like what kind of requirements we have. So like what do we need it to do? What kind of voltages do we need it to handle? How high do we want it to be able to go? What like are the alternatives to it? All that fun stuff. So we'll do a whole like design process and then also a build it process. So the most important thing on this board, there's our processor. It's a STM chip, as we showed you earlier. Essentially, it's like the processor in your laptop, but a lot simpler. Oh, and there's a backside to this board too. Oh, here it is. Yeah, there we go. It's the back of the board, all the connectors. Lots of connectors. Yep, LEDs that we can flash on the board. And then there's also a schematic. Yeah, what do I want to find? I want to go to something that I'm going to understand better than this. I'm going to go look at what we did last year. The only thing in that folder was a things to fix document. I'm trying to find a picture of what the eBay looks like. Oh, I think this is the wrong year. That's why.
I have an incomplete picture of the eBay from earlier this week. Do you want that?
I think I know what I'm looking for.
Okay.
It just isn't archived properly because it's in this folder. This should have something. Not for presentation edition, our copy. You know it's legit. Ah, there we go. That is a terrible view of the electronics bay. Ah, I mean, there's the dual deploy board PCB. No, that's not good. Close. Okay. There's an accurate picture of what our eBays look like. So here are those dual deploy boards that I showed earlier. So like an Arduino-based board that we have in the Rocket. We're integrating this functionality into other boards at this point, so we don't have a separate board that is extra wires and mess. Because as you can tell, there's lots of wires and mess. Is there the other side? Yes, here's the other side. So here's the actual altimeters. So there's two easy minis down here, which are the small altimeters, and then up here is a bigger altimeter called a telemega. All you need to know is that we have these altimeters that go into these eBays. So what these altimeters do, as I said earlier, they measure the altitude. So when you're at a certain altitude, it fires a signal. And that's really all it does. There's a whole bunch of other safety procedures, a whole bunch of other code on this board. It also like has a little buzzer for when it finishes whatever its flight is. It can let you know where the rocket landed because you can hear the buzzer. But what my plan is to try to do in the spring is to design a replacement for something like this, so that we can build it in-house, and also be a good opportunity to build something that's real, that's going to be used. So we're going to use it in the intro airframe rockets. So that's one of the other intro groups. Airframe is building rockets, and we're going to use the altimeters that we make from this group in the spring to also work in their eBays. So I've already given a size requirement, so we're limited how big it can be. But it's actually a lot bigger than these, so we're fine. But we're gonna put sensors on it, figure out how to program sensors, how to design the board, and that is the plan for the spring. If anybody has questions about that, feel free to chime in. I'm kind of lost. I don't know what I'm going to talk about now. Should have thought about this more. Oh well. Yeah, 1 second. Okay. Does anyone have any questions about how rockets, how the electronics in rockets work? Because I think we've kind of I've talked about a whole bunch of random stuff over the past few weeks. I'm trying to tie it all together so that you guys have a better idea what we're actually working on, and what's actually what is there for you guys. I've heard this asked before, what are we gonna do? That's what I'm trying to figure out.
With the PCB design stuff, is there methodology to I get how to design once you're in Eagle, but how's the process of knowing what you want and where you want it work?
Yeah, so that's kind of up to whoever's designing it a lot of the time. So we kind of pick the sensors that we want. So we say we want this barometer. We do some research on that. We find a barometer that we think meets the specifications we need. So it can go as high as we want. It can measure as accurately as we want. And then we take that and we try to, and then essentially we just put those on the board wherever they think they'll fit. There's some other design concerns. If you're doing, I think on some of those boards they had connectors or headers. And when you're doing those, you have to think more about oh, is this angle make sense, or is this going to be a pain to plug in a connector under the board at a 45-degree angle? It's going to break all the time. So that's kind of also something that we really haven't thought about a lot. But also normally with sensors, we kind of know what we're going to use. We've kind of used the same type of sensors a lot, but it's also it's a part of the design is figuring out what makes sense.
Yeah, you end up looking at a million different data sheets and going down a lot of rabbit holes.
So I mean, essentially the goal of what we're going to try to do is to help get you guys up to more of the help you guys get up to speed and get up to the point where you can by the end of next spring, I'm hoping that people everyone in this call will be able to contribute to what DPF is doing, because we graduate, we need people to continue bringing up behind us, as always happens, and this is the first time where we've actually had an opportunity to try to teach people and not just say, okay, here's the thing that needs to happen, go try to figure it out, because that's what we did to John, and he did. And he built PCBs, and we didn't know how to build them ourselves, and he just did after 6 months of staring at websites. And that doesn't work because you only get people like John once in a while. It's the whole idea we have to try to help everybody learn things better. What else do I have to show you? I'm trying to find interesting things to show because okay.
I mean, you went over the FCBs, right?
Yeah.
I'm thinking you could. I mean, there's other stuff that avionics does, such as the data processing thing that Matt's working on right now, and the nose cone board.
Yeah.
Well.
I mean, I didn't really want to go too in detail on those, just because I was just kind of because that's the project that I have planned for intra-group in the spring, is to do the smaller version of the MCB. So that's kind of why I brought that up, because I'm oh, that's a good starting point. Oh, we can show that, move on from there. Whereas we're going to do a simpler version of that, so it kind of gives you an idea of what is going on. But the other stuff in DPF is if that's what you're interested in, if you're really interested in data processing, we will work on getting you in with them on that, because they know more about that than I do. I don't know data processing at all. I don't work on that. I've done a little bit of visualization stuff in Python, but I have no idea how to do filtering or control theory. It's probably as confusing to me as you guys some of the stuff I talk about is, because I have spent a lot of time working on these types of systems. Let's see. I'm going to find. I'm just going to show you a video of what these things look like when they work, because I'm going to guess that none of you have actually seen a stratologger or one of these altimeters working. So here we go. I turned my video off and I meant to share my screen. So what this guy is doing here is he's putting this altimeter in a vacuum chamber.
Tyler, we can't hear the audio from the video.
Oh. Okay. Well, then I will not bother to actually play the video. I'll scrub through it.
You can share the audio, you just have to change some settings.
Oh, you're right. You're right.
Set that for a specific altitude. Well, how do you
That fix it?
Yeah.
know how
Okay.
accurate it is? Well, one of the little tricks that you can do to measure the accuracy is to use the altimeter 1, because the altimeter 1 has this special feature called the current altitude, and that will allow you to see what the altitude in the vacuum chamber is.
So another way to do this is the way that we've done this. Oh, I just got the message in the chat. The way that we've tested altimeters in the past, and what we'll do when we actually build the altimeter in the spring, is we'll come through, we'll design a whole testing procedure, because we're going to have to test this a ton before we actually fly in a rocket, because you can't just fly something in a rocket without knowing if it works. So what that essentially ended up being was we stuck it in a syringe. So with this giant syringe that we bought online, and we'd stick our altimeters in there because we didn't know which ones worked and which ones didn't, because a bunch of them had like been in lakes or something, or like been in the woods for 3 years and still worked somehow. I don't know how that happened. So we would essentially build this apparatus that he's doing here, where you have like a chamber. We would just use a syringe, and you'd pull back the syringe to make the pressure go down and make sure it still works as expected.
When your ejection charge goes off. So I talked about this before on the altimeter 1 video, but to set that, you just hold down the red button. It'll go through 0 current, and when it gets to current, you let it, and now it's set at the current altitude. So you can see it's kind of drifting a little bit, and that means that it's sensing the pressure. So at this point, what you would do is you would turn on your altimeter, and we're going to let it run through its cycle, and then we're going to kind of pause here, and then we'll be right back as soon as it's done here.
So you hear those beeps? I spent
Okay,
a lot of my life
the
listening to these
altimeter is ready. This is the altimeter. I hooked up an igniter to simulate the ejection charge. So when the igniter fires, it will tell us, we'll look at the altimeter 1 to see what our altitude is. So I'm going to go ahead and put the bell jar on here. And I got to kind of get it at an angle here. Okay. It's very hard to read. I'm sorry about that. I'll read it off for you. Okay, I'm going to turn on the pump here. Okay, now the pressure's going up. Okay, at this point I turn it off and my vacuum chamber leaks a little bit. So right now we're at 30,000 feet and it's dropping pretty fast. And the pressure is coming down, which means the rocket is coming down in altitude.
Pressure's going up.
1,800 feet, 1,500 feet. Okay, 900 feet, 8, 7, 6, 5.
There you go.
So that was perfect.
Except we don't do it with fire.
So that is the way you would test your altimeter, your dual deployment altimeter, to make sure it's deploying at the proper altitude. And it's pretty simple to do.
So that's the same exact test that I've done before, except we did it with syringe and we did it with a little LED. So we took a strand of Christmas lights and we pulled the LEDs, like the little actual lights, out of the strand of Christmas lights, and we would like hook them up to the little thing in the tube. We pull back the syringe and see where it went off, and we didn't have another altimeter in there like showing us the altitude. So what we do is we take it. You can plug them into your computer and then pull the data off. And then when we pulled that data off, we could read back through and see like, oh, this is the altitude it actually fired at. That looks right. Probably I should actually do that with another altimeter. But we tried to do some math and like figure out how far back you're supposed to pull the syringe, but it leaks. It's not very good. But it works. The test works, and that's how we verified that all of our altimeters that had like been in rockets that crashed still work. So that's the kind of thing we'll have to do when we do the board design, is we'll have to go through and figure out a set of like different tests that we have to run to make sure that it works the way we expect it to. That kind of goes into testing as a theory, a mindset, and something that we really need to work on as a club is designing our tests and not just like, oh, let's just do this, because that's normally how we do and just keep messing with it till it works. And then going on from that, I'm trying to find something interesting to show. I'm going to go show the first board that I ever worked on here, way back. Let's see, this one. Testing and production is a valid strategy. Well, yeah. Oh, detour. I'm showing you guys my intro rocket. There's my intro rocket. We don't know what happened to it, but it has a whole. The paint didn't stick very well to the nose cone. Yep, that's what intro used to be. We just built a rocket. But what I actually came in here to show. Yeah, Matt, I heard you're writing the software for that, and I was kind of like, oh, that's interesting. I thought we had software for that.
We did. I just helped restructure it, and then some stuff changed, and yeah.
Okay. Because I was gonna do it, so I was supposed to do a safety review on that rocket, but except no. So I'm gonna go here. Oh, guess what? They don't exist anymore. There we go. There's got to be a picture of me in here somewhere with an antenna. No, my board isn't in here. Oh, there it is. Oh, that's the eBay. So this is more specific. So the board that I actually want us to replace is this little red board you see right in here that I'm highlighting. It's called a Stratologger. It was just made by a random guy named John, and John's mom wasn't doing too well, so we had to stop making Stratologgers, and he hasn't made them since. So you can't buy them anymore, so we're going to make a replacement. Oh, of course, it's upside down. This was my board. It was on the other side of this blue plastic thing. So that was the board that I made back then. It was really janky and really terrible. But I recorded like 8 data points on the flight. And like kind of knew how high it went, which was cool. Yeah, that's all we got there. What about the other subscale? Better picture from that one? Nope. You can kind of see how rocket launchers work. Let's see. Where is... There's a good picture. It's so beautiful. Like rockets. Let's see. If I get the right day on this one. Yep. And then we look, there should be a picture. Oh, yes. This was my workstation in the hotel room. So we have a drill battery. There's my battery bag full of lipos. There's a box of random wires. Yeah, we left this table in terrible shape. I don't know how we didn't get charged for that. And for some reason, a jar of peanuts. But where? Did we take a picture of the eBay? No, we didn't. Oh, wait, right here. More janky wires. Look at all the janky wires. We need to be better. There's one thing you learn from today. It's less janky wires. I'm so bad at being distracted every time someone joins. I hear the da-ding, and I'm like, squirrel. Okay, so yeah. What else can we do? Let's. Okay, so I kind of have an idea. If there's anything anyone else wants me to talk about, let me know now, because I'm just going to dive into this. And okay. So this website right here is an online Linux command line. So this is kind of different than the other thing we talked about, but I know at some point people were interested in discussing a little bit of like how Linux works and like what we use it for, kind of what it is. So I'm just going to share my screen and show you guys a bit of the embedded Linux side that we've done, and that, I don't know, some interesting things about it. So first of all, whenever you're working with like Linux on like a board in a Rocket, you don't have a screen. So you can't just like use a computer the way you normally use a computer. You have to log into it over the network. So essentially you're given, all you have is this command line. So you're given like a place you can type things into and get responses. So like if we just do, make it say hello. So it's that kind of thing of you connect into this remote computer that we have like running a board inside the Rocket, and we can use this to run code during flight that like will do some of the like data processing for us. And also, if we get to a point, we can use these kind of systems. So like we can use like a more, like it's essentially putting a computer inside of the Rocket rather than a microcontroller like an Arduino. It's like an actual computer that can run real code and like run actual programs. So we can do things like tell it, so we can do things like tell it to do more complicated calculations and like do, like we talked about, I think I mentioned computer vision, so we can have it take pictures with a camera, and then on this like embedded processor, like this Linux processor inside of the Rocket, we can figure out like, oh, the horizon is there, we're this high up, all that other fun stuff. Essentially, it's a much faster computer. It runs like an actual computer, and you can use it like this. Yeah, no. I'm gonna stop recording. It's not gonna work.